So by definition, mathematically, the square root of -1 is equal to I. Meaning, like, that's why we always say we pull out the negative and we get an I, basically. So if we have the square root of -n, that's the same thing as the square root of -1 times n. So we'd pull out the -1, and that would be I, like that, right? We've seen this a million times in our math careers by now. So everyone, what would be the square root of -16? 4i, right, everyone? You see the pattern here. So then what would be the square root of -3? I square root 3, because in this one the root doesn't simplify. So wouldn't this be I root 7? And then wouldn't this one be 7i? So pretty basic stuff. So that's where i's come in. Now a complex number has this form, a plus bi, where a is the real part of the number and bi is the imaginary part. Real part, imaginary parts. We always write complex numbers in the form of a plus bi. So the real part is written first. So 3 plus 2i is a complex number. Here's the real part, here's the imaginary part. Very straightforward. We always write it like that. So we would not write it as 2i plus 3. Our final answer we wouldn't write like that. Okay, so it says write each of the following as a plus bi. So what is this? 2 minus what? 5i. Isn't that a plus bi form, everyone? Pretty easy. Yes. Okay, let's look at another one. So this would be 3 plus I root 50. But now we have to check, does our radical actually simplify? So that would be 5 times 10, 5 times 2. So actually, shouldn't we pull out a 5 as well? So we'd have 3 plus 5i root 2. And that is a plus bi form. Okay, let's do this one. So first of all, could I divide 4 and 2 out?
No,
Good. No, there's a subtraction sign. We don't divide across subtraction sign. So instead you'd say, okay, I got to simplify this. 4 times 3, 2 times 2. So what do we pull out of 2i? So we have 4 minus 2i root 3's all over 2. Now we have seen in this unit so far, if all three things can divide by something in common, it is appropriate to divide all of them, as long as you're dividing all of them and not just 2 of them. So you'd say they all divide by 2. This becomes a 1, a 2, and a 1. So our final answer here would have been 2 minus I root 3. Divided by 1 does not need to be written. A plus bi form. Okay, so when adding complex numbers, you can only combine real numbers with the real numbers and imaginary numbers with imaginary numbers. Really straightforward. So, this is an addition sign. Guys, people get to the test and they miss the easiest problems because they see parentheses and just assume it's multiplication. No, it's addition. So combine real parts with real parts. 4 plus -2. 2, negative 3i plus 5i. 2 plus 2i then. There it is, a plus bi. Pretty easy. Addition again. So you'd say, well, first of all, let's actually simplify this. We're actually looking at this. 4 plus 5i plus sign 6 minus 4i, aren't I? So now 4 plus 6 is 10 plus 5i plus negative 4i is 1i, isn't it? 10 plus 1i. Subtraction. People, we cannot miss these easy problems just because it's a subtraction sign. With a subtraction, shouldn't I take it and distribute the negative in? So this is negative 3i minus 7i. Negative 3 minus 7i. Now we have minus 5, and now we have plus 4i. So write it out with the negative distributed through, and then you're good to go. Negative 3 minus 5 is negative 8, isn't it? Negative 7i plus 4i is negative 3i. A plus bi form. So subtraction, just like with all the problems we've done this year, you got to distribute the negative. So this would, you'd say, okay, this is actually 3 plus, you got to break this down, isn't that 2 times 2 times 3? 2i root 3. 3 plus 2i root 3's, minus sign, negative 2, and then 27 is 3 times 3 times 3, so minus 3i root 3's. Now you'd say with subtraction, I got to distribute the negative. So this doesn't change, this front one. 3 plus 2i root 3's. Now we have plus 2, so we distribute the negative in. Then we have plus 3i root 3's. Combine real parts with real parts. 3 plus 2 is 6. Now are these like radicals? I root 3, I root 3? Are they like radicals? I root 3, I root 3. 2 apples, the apple part's the same. 2 apples plus 3 apples is how many apples? So it's 5i root 3's. Oh, yeah, it's 5, not 6. I multiplied them in my head, didn't I? So we have 5 plus 5i. I did that twice.
Really?
Oh, no, not right there. That's why I did it twice. 5i root 3. Not multiplication. Addition, yes. No, we're just simplifying. How do you, like, remember how we break down square root of 12? We break it down into its factors. 4 times 3, 2 times 2, and then aren't we pulling out groups of 2 because it's a square root? So we're just doing it the same. It's just now it has an I because of the negative. So how would we simplify a cube root? Pull out groups of 3, right? Well, we wouldn't have i's with cube roots. Okay, so now guys, because the square root of -1 is I, which we just saw, then isn't it true that if I square both sides, root cancels out with power? Isn't it true that I squared equals -1? Yes, okay, so let's multiply this out. 4i times 3 is 12i. 4i times -6i, be careful here, that would be -24, and then I times I is I squared, isn't it? So now you'd have to remember, a plus bi is the format of a complex number. We shouldn't have I squareds. I squared is equivalent to -1, so this is really this, 12i minus 24 times by -1. That's a times sign, not addition sign, a times sign. So doesn't that become 12i plus 24? So then we just say, okay, complex numbers are a plus bi, so our final answer is 24 plus 12i. Multiplication now. Okay, let's multiply this one out. You'd say 2 terms times by 2 terms calls for distribution. -2 times 3 is -6. -2 times -i is plus 2i, isn't it? 4i times 3 is plus 12i. Then right here is usually where people mess up. They just put an I on this one, which it's not. 4i times -i is -4, but then it's I times I, so it must be I squared. So now we have this, -6 plus 14i, and then don't we have -4 and then times by -1? I squared is -1, right? So isn't that actually just plus 4? So then you'd say -6 plus 4 is -2. A plus bi. All of your answers should come out always with complex number as a plus bi. Okay, so I think we get the picture here. How would I write this one? This would be 2 plus 6i times 4 minus 5i, and then I would double distribute, right? Are we all good? Okay, moving on. Okay, so let's look at this one, because something interesting happens here. We have conjugates, don't we? That doesn't change what we do. We just multiply it out, but watch what ends up happening with conjugates. This is important to us. 4 times 4 is 16. Then we have minus 12i. Then we have a plus 12i, which makes sense because all conjugates will have a middle term cancel out. Then right here, don't mess it up. That's -9, and then it's I squared. So now combine like terms. Our middle term should cancel out. We have 16 minus 9 times by -1. Don't call that -10. Don't call that 8. That's times sign. So that's 16 plus 9, which is 25, right? So now it became a whole number without i's. So that'll happen with imaginaries with conjugates. It'll cancel out the i's. Yep, and then it becomes a real number. Okay, so now let's talk about dividing complex numbers. Guys, just like it's not considered appropriate, look, if I had this, 3 plus 4 root 2, for example, all over the square root of 2. Is it appropriate to have a radical in the denominator? No. Well, it's also not appropriate to have an I in the denominator. So we quote-unquote rationalize the denominator. We're not actually rationalizing because that's what this is. We multiply by root 2, don't we? So the top and bottom, everyone here. We got to get rid of I. So we can't have an I in the denominator. So if you can remember, what isn't I squared negative 1. Well, negative 1 is not an I. So let's make this I go away by timesing by I. So let's times by I to the bottom. 2 terms on top, so we times by I on top. So now we would need to distribute I through. So we'd have 3 times I, which is 3I. Then we have I times 4I, so that's plus 4I squared on top. Which isn't that 3I plus 4 times negative 1? So then that's 3I minus 4. So on top, we actually have a plus bi would be negative 4 plus 3I on top. I's can be on top, but now on bottom, don't we have 2I squared? Which is, what? 2 times negative 1, which is negative 2, everybody. So now we have a negative 2 on bottom. Now we've fixed it so that there's not an I on bottom. This and this are actually equivalent mathematically. It's just it's considered more appropriate to not have an I in the denominator. Fun fact for you, if you check the book, with this answer, they don't also like negatives in the bottom, so they would have taken the negative to the top. So this would have been positive and this would have been negative. Okay, so... No. Try to remember it though, just for, future math. Some math teachers might in your future math. Okay, what would I need to do? Multiply by what? I put parentheses I. So then that would be negative 4I plus I squared on top. And then that would become negative 4I minus 1, wouldn't it? Plus negative 1. And then on bottom, I would have 3I squared, which is 3 times negative 1. So on bottom, we'd have negative 3. Now, once again, they will not keep that negative on bottom when you're checking your answer. So they'll say, I'm going to take it to the top. So I would change that sign, change that sign. So the answer in the back of the book or on the side would be 4I plus 1 over 3, which is the equivalent answer to yours. Okay, so looking right here, just a reminder, let's say I have this, 4 plus 2 root 3 over 1 minus root 3. How do we rationalize the denominator here? Multiply by the conjugate. If there's 2 terms, you got to multiply by the conjugate, so we'd multiply by this to the top and bottom. Well, the same thing happens here. If we have 2 terms, to get rid of I, we multiply by the conjugate. So we'd multiply 1 plus 3I. 1 plus 3I. So then we would distribute out the top. 4 times 1 is 4. 4 times 3I is plus 12I. Then we have plus 3I. Then we have plus 9I squared. So on top we would have, this is minus 9 now, because positive 9 times negative 1 is minus 9. Negative 9 plus 4 is negative 5. So then we have plus 15i's. And then on bottom, let's multiply this out on the side. 1 times 1 is 1. We have a plus 3i minus 3i. Middle terms cancel out with conjugates, so I'm not going to bother writing it out. And then we have minus 9i squared. So that's 1 minus 9 times negative 1. So that's 1 plus 9, which is 10. So now we fix it so the radical, or not the radical, the i's not on bottom, but what do they all three divide by? 5. So if they do divide by something in common, obviously that's your last step. You'd say, okay, they all divide by 5. This becomes a 1, a 3, and a 2. So negative 1 plus 3i all over 2. That would be your answer. Now your book is going to split it up. A plus bi. As long as we divide both of them by 2, it is appropriate to go, that's negative 1/2 plus 3/2 I. That's how your book's going to write it, because that's a prettier A plus bi form. Do you see how I just split it up? As long as you keep the denominator on both of them, you're okay. Okay, awesome. Okay, what would I multiply by? I won't go through the whole thing, but what would you multiply by? 5 minus 3i. Good. 5 minus 3i. And then you distribute that through. Awesome. Okay, let me just look here. Good. Okay, awesome. Okay, this is the last part of the lesson. Super easy stuff. But this part always is hard for people because, I don't know, they're not very creative, I guess. But you'll see that it's actually really easy. Okay, everybody. We're going to now look at how we can simplify any powers of I. So, we know that I squared equals negative 1. That is equivalent. So, negative 1 would always be better than I squared. Now, so what we have is, for complex numbers, we have A plus bi. So it's either just one I or no i's, correct? One I or no i's. That is a complex number. So everybody, I to the first is I, and I to the second is -1. So we want everything written in powers of I to the first or I squared, because we know what those simplify to be. I and -1. So for example, if I said to you simplify I cubed, we want to always with these write them with either I to the first or I squared. So what is I to the third the same thing as? So yes, yeah, not plus but times, but yes. So this is what, but what is, let's write it in terms of i's and I squared. So wouldn't that be I times I squared? Isn't there 3 i's there? When you multiply, you add, right? So now that would be I times -1, which is -I. Now that's more simplified. Your final answer should always come out to be either a whole number or with an I. A plus bi. So I to the fourth, what's that the same thing as? I squared times I squared, which is -1 times -1, which is 1. So you guys, there's many ways to do it. Couldn't I have done I times I times I times I? Then we would have said, okay, well, then that's I squared and I squared. You can see what you can do. You can kind of work your way through it. So you always want them in powers of 2's or 1's. So let's go to some harder ones. I to the fifth. Yeah, so we just want to get them all in terms of I to the first or I squared. Rewrite it. So how could I rewrite this one? There's many different ways. I squared, I. Does everybody see why he said that? That is one way of doing it. True. Wouldn't it also have been true to say I squared times I? Raise a power to a power and you multiply. 4 plus 1. You guys see how there's many different ways. So I like this way a lot. Isn't that -1 times -1 times I? Which is I. Yeah, it does. So I to the sixth. And now a lot of teachers will teach you to memorize more than just I to the first and I to the second, but I think it's too hard. I just like to do it in terms of 1 and 2, because we can always write them in terms of 1 and 2. So 6. So that's I what? I times I squared, that's 3. So then I squared, so that's 4, 5. So what do I need another in? Another I. So shouldn't I do I squared probably? You guys see? So then that's -1 times -1 times -1, which is -1. There's going to be some bigger powers where we have to think a little bit more creatively. So let's look at someone like this. 34. Now you could get desperate and write out a bunch of I squareds. That's fine. But I'm going to try to think a little bit more advancedly here. So we definitely need it to be I squared raised to some power. Now 34 times, so divide 34 by 2. 17, right? So isn't raise a power to a power and you multiply? So 17, that is equivalent. So now don't we know this is actually just -1 to the 17th power? You guys see what I'm kind of going for there? So then -1 to an odd power will be that same thing, right? So that'd be -1. There's many ways to do it though, yes. No, because it could come out to be -1, -I, or 1. So it could be any of those. It'll always simplify to be one of those though, but it's hard to say without doing it out. Because what if I would have made this 35? Then we would have done squared to the 17th, but that's only 34, right? So then I would have needed to put another I here. So then that would have been -1 times I, if that makes sense. Let's do this one, 101. So everybody, I like it to be evens, like this doesn't divide by 2, does it? So instead I'm going to say, well, 100 does. So I'm going to do I times I to the 100, and then I'm going to say, okay, I, and then this is I squared raised to the what power? 2 times what equals 100? 50. So then we have I times -1 to the 50th power. So oh, but right here I see what you're saying. Maybe this is what you're talking about. Yeah, this is true. So this will be positive, won't it? Yeah. This will either be, she was saying right here, is either going to be +1 or -1. True? So even would be, yes, +1 like you were saying, and an odd would be a -1. I get what you're asking now. Okay, so we have I times 1 which is I. That is the same thing as I. So you just get creative. Last one, I to the 15. It doesn't divide by 2, does it? So you're already seeing it. It's negative I. So I'm going to go like this, though. I, because a lot of people can't just see it. And then I squared raised to the, I made it 14, because doesn't 14 divide by 2? So then that'd be 7. So then that's I times negative 1 to the 7th. So then that's negative I. Yeah, you're seeing it quick. Awesome. Yep, true. Yep, that's true. That's a good way of thinking of it, too. Okay, awesome. That's the end of the lesson. So you have about a little under 20 minutes, 15 minutes to practice some of that caliber